Okay, so what I'm going to do here is in fact show that the Markov chains in the last video were recurrent or transitive by looking at the summation of n equals 1 to infinity of p to the n, and then pulling out the individual values and checking, hey, is this equal to infinity or not? All right, so we'll start with this first example. I'm going to go ahead and clear and CLC, so that deletes all the variables and makes the screen nice and pretty. So I'll define our P matrix as 0, 0, 0.5, 0.5, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. Okay, so I now have my P matrix. Let's see if I can. Okay, so there goes my P matrix. Hopefully it matches what we expected. So let's pretend, again, we know all these states communicate. So all I need to do is figure out whether one of the states are recurrent, right? Because if one state is recurrent and it communicates with all the other states, then those states must be recurrent as well. So let's just look at state 1. Okay, so I'm going to pull out this 1, 1 term every time I take out p to the n. So first we pull out 0. All right, now let's take p squared. We're still going to pull out 0. P to the 3. Oh, now we got 1. All right, p to the 4. We got 0. Well, this might be a little bit weird, and we'll learn about why this is weird. So then we get 0. Actually, I'm going to rewrite this a little bit differently. 0 plus 0. See what happens when we do it again. P to the 6. We get 1. All right, let's do p to the 7th. We get plus 0. Plus 0. Any guesses on what's going to happen next? We get 1. And in fact, we see the same pattern repeating where you get 0 plus 0 plus 1. And this is going to repeat infinity times. So if we add 1 up infinity times, this is going to end up equaling infinity. So what this tells us is state 1 is recurrent. And because 1 communicates with 2, 1 communicates with 3, and 1 communicates with 4, this implies states 2, 3, and 4 are recurrent as well. All right. So that kind of is how you would go about showing your work, right? Using this, the method we defined earlier. Okay. So now let's do it for the other problem. So on the other problem, our transition matrix was 1/2, 1/2, 1/2, 1/2, and then we had a bunch of zeros. And then we had states 3 and 4 that were going back and forth with the half as well. And finally, a fifth state with 1/4, 1/4, 0, 0, 1/2. Okay. So I'm going to focus in on, let's see. We'll start by studying state 5. Maybe we'll study state 3, state 1, and then state 3. But really, I think this is a good one to look at probably, and state 1 as well. The rest are, doing the other ones are just repetition. Okay. So again, well, let's do this for state 5 first. We're going to look at the sum of p to the n power and pull out the fifth element, 5, that diagonal, for n equals 1 to infinity. And so first we get 1/2. All right, so let's... Okay, so p equals... Okay, so I have my P matrix here. So again, this last element, this 5, is equal to 0.5 right there. So now let's take P to the second power. We get 1/4. And hopefully you know where this is going already by watching the last video. 1/8. And if we keep doing this, it ends up just being, we're just going to keep adding 1/2 to some n power, right? And we add it up. We already know the sum of the series. It's equal to 1 minus 1 over 2, which I think is 2. So this is less than infinity, which tells us state 5 is transient. Okay. Let's look at maybe state 1 and see what happens there. Okay, so again, we're doing a summation. We're going to take 1 to infinity. We're going to take p to the n power, and we're going to pull out the 1 element. Okay. So p, we start off 1 is 1/2. Okay. Let's take p up 2. All right. Still get 1/2. P up 3. 1/2 again. Four. 1/2. So if you're looking right here, okay. 4, 5, and you can see I keep getting 1/2 no matter what power I take this to. So I could do some random matrices, and again, I'm getting 1/2 here. So in fact, what I keep adding is 1/2 plus 1/2 plus 1/2 plus 1/2, and we're going to do this infinity times. So the sum will end up being infinity, which implies that state 1 is recurrent. Because state 1 communicates with state 2, then this implies that state 2 is recurrent as well. So there you go.